So good morning to everyone. இன்னைக்கு என்ன பார்க்க போகிறோன்னா that is monotonic sequence. நேற்று பார்த்ததனுடைய ஒரு continuation. So monotonic sequence means that is either increasing or decreasing sequence அர்த்தம். So the monotonic sequence is either non-increasing or non-decreasing or both. That is called that is monotonic sequence. So the sequence of the real number that is called the non-decreasing abdina like this s1 s less than or equal to s2 less than or equal to s3 less than or equal to sn less than or equal to sn plus 1 and so on. Then the sequence is called the non-decreasing, that is means increasing. அதே மாதிரி நான் இன்க்ரீசிங் அப்படின்னா தட் இஸ் s1 greater than equal to s2. நான் இன்க்ரீசிங் மீன்ஸ் தட்ஸ் நத்திங் பட் த டிக்ரீசிங். ஸோ இது மாதிரி குறைஞ்சிட்டே வரும், தட் இஸ் கால்ட் த நான் டிக்ரீசிங். greater than equal to something, sn is called the non increasing அப்படின்னு அர்த்தம். ஸோ த மோனோட்டான் சீக்வன்ஸ்ன்றது எய்தர் இன்க்ரீசிங் ஆர் டிக்ரீசிங், எய்தர் இன்க்ரீசிங் or decreasing, then it is called the monotonic sequence. For example pathina, that is 1 and a half like this 1 and a half 1 3 4 1 7 8 7 by 8 and so on like this. This is the 2 minus 1 by 2 power n minus 1. This is the sequence. This sequence is called the non-decreasing sequence. That means increasing sequence. This is the increasing sequence, that is non-decreasing sequence, and also it is called the bounded. It is bounded, so that is lower value is 1, upper value is 2, so that it is bounded. And also the n is a non-decreasing increasing sequence, that means 1 2 3 4. This is called the non-decreasing. So that means increasing sequence, that is unbounded. This is unbounded. Examples maximum ஞாபகம் வச்சுக்கணும். And non-decreasing, that is increasing, non-decreasing sequence which is bounded above, the sequence is called the convergent. Very very important result. This is a very very important result. ஸோ நான் டிக்ரீஸிங்காக இருந்து அதாவது இன்க்ரீஸிங்காக இருந்து ஓகே பவுண்டட் எபோவ் இருந்ததுன்னா இப்போ இது ஒரு இன்க்ரீஸிங் சீக்வன்ஸ் தான், பட் இதுக்கு அப்பர் பவுண்ட் இருக்கானா இல்லை, பவுண்டட் எபோவ் கிடையாது. ஸோ திஸ் இஸ் நாட் எ கன்வர்ஜென்ட். பட் நான் டிக்ரீஸிங் சீக்வன்ஸாக இருந்தது பவுண்டட் எபோவ் இருந்ததுன்னா த சீக்வன்ஸ் இஸ் கால்ட் த கன்வர்ஜென்ட். அண்ட் த சீக்வன்ஸ் 1 plus 1 by n, okay, this is the convergent sequence. Okay, that is 1 plus 1 by n whole power n, 1 plus 1 by n whole power n உடைய value பார்த்தீங்கன்னா that is as n tends to infinity, this is equal to e. The e உடைய value பார்த்தீங்கன்னா this is always lies between the 2 and 3, 2 less than e less than or equal to 3. Okay, the value of the e is always lies between the 2 and 3. Exact value, approximate value for this one e ki 2.718 and so on. Okay, this is the transcendental number. And a non-decreasing sequence which is not bounded above, then diverges to infinity, the good example that is called the n என்றது good example. அதே மாதிரி நான் இன்க்ரீசிங் சீக்வன்ஸ் விச் இஸ் பவுண்டட் பிலோ, நான் இன்க்ரீசிங் சீக்வன்ஸ் தட் டிக்ரீசிங் சீக்வன்ஸ் பவுண்டட் பிலோ இருந்ததுன்னா தட் இஸ் கால்ட் த கன்வர்ஜென்ட். ஏற்கனவே பாத தேரத்தினுடைய கான்வர்ஸ் மாதிரி, தட் இஸ் அதர் வெர்ஷன். and a non-increasing sequence which is not bounded below na, that is diverges to minus infinity. This is diverges to plus infinity. Okay, this is diverges to minus infinity. Okay, that is a very important. Okay, in the knowledge result very important. The sequence Sn of real numbers, then S equal to Sn be a sequence of real numbers, then S has a monotone subsequence. For a sequence of real number, that sequence has a monotone subsequence. That means either increasing sequence or decreasing sequence subsequence. And the sequence an equal to n by n plus 1 is monotone and convergent. Monotone and convergent. Monotone means either increasing or divergent. Increasing or decreasing. So an equal to n by n plus 1. Okay, that is increasing decreasing check பண்றதுக்கு the simple way அப்படினு பாத்தீங்கன்னா an plus 1 minus an கண்டுபிடிக்கிறது. an plus 1 ன்றது n plus 1 by n plus 2 minus of an ன்றது n by n plus 1. இங்க LCM எடுத்தீங்கன்னா that is n plus 1 whole square. Okay, n plus 2 n plus 1 ரெண்டுதனுடைய product. Here this n plus 1 இங்க multiply ஆச்சுனா that is n plus 1 whole square minus n into n plus 2. So இது a plus b whole square formula experiment பண்ணிட்டு simplify பண்ணீங்கன்னா 2n cancel ஆயிடுதுன்னு நினைக்கிறேன் and n square cancel ஆயிடுது. மிச்சம் இருக்கிறது 1 by something வருது, 1 by n plus 1 n plus 2. So this is always positive, so 1 by n plus 1 n plus 2. an plus 1 minus an should be greater than 0, that means an plus 1 greater than an. So that means an less than an plus 1, an the first one, less than an plus 1. So that means increasing sequence, that is strictly increasing. Okay, so that's strictly increasing and therefore non-decreasing in artham. So non-decreasing sequence, and since an equal to how to express the an is n by n plus 1 actually. An is n by n plus 1. So we can rewrite this one as n plus 1 minus 1. Okay, divided by n plus 1. So then n plus 1 by n plus 1 minus 1 by n plus 1. So this is become the 1 minus 1 by n plus 1. So this is the an. Okay, so this is as the n tends infinity, this is become the 0, so this is less than 1. So this is an equal to 1 minus 1 by n plus 1. This is less than 1 for all n. For all n. So the sequence is bounded above. The sequence has the bounded above, and non-decreasing sequence. Okay, upper bound irukku, that is increasing sequence upper bound irukku. So then by the above theorem this is converges. So what is the convergent padina? As n tends infinity, this is converges to 1. This is converges to 1. So idu or example. And bn equal to 1 by n. It is also monotone, that is monotone sequence. That means an plus 1 less than an plus 1 less than an for all n belongs to n. So the sequence is strictly decreasing sequence. Am I correct? So an plus 1 less than an, an greater than an plus 1. Okay, greater than an plus 2, like that. So this is the decreasing sequence. That means non-increasing sequence. Non-decreasing sequence, decreasing sequence, non-increasing sequence. It's what about the bounded below? Bounded below by 0. The sequence as a bounded below, that is lower bound is 0. Okay, so that is from this what is the conclusion appdi pathina? Non increasing and bounded below irukku, then the sequence is converges. So what is already namakku theriyum, idu familiar ana sequence. So limit n tends infinity 1 by n என்றது 0 னு வந்துரும். that is converges to 0 னு அர்த்தம். And another example பார்த்தீங்கன்னா cn equal to n square. n square பார்த்தீங்கன்னா non decreasing, that is increasing sequence and bounded above unbounded. So by the it is diverges to infinity, it is diverges to infinity. Okay, so it is not bounded above, not bounded above, so the diverges to infinity. Okay, and every convergent sequence is bounded, every convergent sequence is bounded, but not every bounded sequence is converges. Every bounded monotone sequence is converges, every bounded monotone sequence is bounded, and the sequence is 1 plus 1 by n whole power n approaches to e value is 2.71828, that is lies between the 2 and the 3. Okay, which is the base of the natural logarithm, which is the base of the natural logarithm. E into every sequence, the bounded or not, as a monotone subsequence, as a monotone subsequence. The 4 பாயிண்ட்டுமே ரொம்ப முக்கியமான பாயிண்ட்ஸ் இது. And which of the following sequence is or monotone? The sin n. Sin n என்றது monotone sequence, that means either increasing or decreasing sequence. Already we know that about the sine உடைய nature, sine function உடைய nature. Actually sine function is oscillate function. The sine function is oscillate function, that is look like this is the oscillate function, that is between the -1 and the +1. So the sequence value that is fluctuate and don't maintain the consistent increasing or decreasing pattern. So this is the not a monotone sequence, not a monotone sequence. And what about the tan n? Tan n is also not a monotone sequence, neither increasing nor decreasing. Tangent function is as a periodic discontinuities, periodic discontinuities and oscillator behavior. So that this is the not a monotone sequence, tan n. And 1 by 1 plus n square. So what about the nature of this sequence? That is an plus 1, 1 by 1 plus n plus 1 whole square. This is the an plus 1. What about the an 1 by 1 plus n square? So this is the n square plus 2n plus 1. So n square plus 2n plus 2. So this is the n square plus 1. So the obviously this is less than 1 by 1 plus n square, இல்லையா? So that an plus 1 less than an plus 1 less than an, the an greater than an plus 1. So that means decreasing sequence. So the n plus 1 whole square greater than n square. So that that is the idea. So that is denominator, therefore the sequence is strictly decreasing sequence, strictly decreasing sequence. And so and then this is 2n plus minus 1 power n, that is n equal to 1 to infinity. So what about the nature of this sequence? That is n equal to 1, this is 1, and n equal to 2 na, that is equal to 5, and n equal to 3 na, that is equal to 5. N equal to 4 na, that is equal to 9. So this is 1, 5, 5, 9, 9, 13, 13. So this is called increasing sequence, non-decreasing sequence, and therefore it is monotone sequence. It is a monotone sequence. And இதுக்கு upper bound இருந்ததுன்னா that is converges. So not upper bound, I thought. So the Sn is a non-decreasing sequence and bounded above. Non-decreasing, that means increasing and upper bound, L equal to the limit of the sequence, L equal to the limit of the sequence, then Sn less than or equal to L, Sn less than or equal to L, okay, we want to, the Sn is less than or equal to L, and the corresponding statement for the non-increasing sequence. Okay, so the limit vandu is the upper bound for the sequence. Just use the definition, that is a non-decreasing and upper bound and converges to some limit L. So suppose assume the contradiction, that is Sn is greater than L for some capital N. So the sequence is non-decreasing for all n greater than equal to n. The Sn is greater than equal to Sn, that is greater than L. So for any epsilon, epsilon is less than Sn minus L. Am I correct? Sn minus L is greater than 0. So we cannot have the mod of Sn minus L is less than epsilon for all sufficiently large n. So which is a contradiction, that converges to L. So therefore Sn should be less than or equal to L. So என்ன ஐடியா அப்படின்னு பார்த்தீங்கன்னா, the sequence is non-increasing sequence, that is then the limit is some L, that is less than or equal to L. The sequence is always less than or equal to L for all n. And the rendu sequence irukku, that is both are increasing sequence, non-decreasing sequence, that is the increasing sequence, increasing bounded sequences rendume. Then Sn என்றது less than or equal to Tn, Sn என்றது less than or equal to Tn இருந்தா, the limit வந்து corresponding limit is also less than or equal to அர்த்தம். That is limit of the Sn less than or equal to limit of the Tn. Okay, இதெல்லாம் சின்ன சின்ன ரிசல்ட்ஸ் நீங்கள் படிச்சுட்டு ஞாபகம் வச்சுட்டு இல்லை கொஞ்சம் திங்க் பண்ணி ப்ரொசீட் பண்ணலாம், இல்லை டெஃபினேஷன் அப்ளை பண்ணி ப்ரூஃப் உங்களால் எழுத முடிஞ்சதுன்னா that is better. Okay, so just using the definition, then we get the result. And this is a very important problem maybe. So that is n power n, n plus n whole power n, that is the sequence. So that means an equal to n power minus n, n plus 1 whole power n. That's nothing but in the n power minus n கீழே வந்ததுன்னா n plus 1 by n whole power n. இதை மாடிஃபை பண்ணிங்கன்னா உங்களுக்கு தெரிஞ்ச ஒரு சீக்வன்ஸ் கிடச்சிடும். இதுக்கு நம்ம லிமிட் கண்டுபிடிக்கிறது பெரிய விஷயம் இல்லை. So the limit of the sequence is a standard value, that is called the E. E is sliced between the 2 to 3. 2 க்கும் 3 க்கும் இடையில இருக்கும். Okay, and 10 power n divided by n factorial. இது ஆல்ரெடி பார்த்தோம் நினைக்கிறேன் லாஸ்ட் கிளாஸ். 10 power n divided by n factorial and find the stage capital N such that என்ன capital N னா Sn plus 1 less than Sn. இது மாதிரி satisfy ஆகிற மாதிரி for every after the stage of the capital N, what is the capital N கேட்குறாங்க. So then when you try to find out the ratio, இதுக்கு என்ன அர்த்தம் அப்படின்னு பார்த்தீங்கன்னா Sn plus 1 divided by Sn less than 1 ன்னு அர்த்தம். இதுக்கு மீனிங் வந்து Sn plus 1 divided by Sn less than 1. So Sn plus 1 ன்றது 10 power n plus 1 divided by n plus 1 factorial. Sn ன்றது 10 power n divided by n factorial. So இதை சிம்பிளி பண்ணிங்கன்னா 10 power n plus 1 divided by n plus 1 factorial. இதை ரெசிப்ரோக்கில் எடுத்தால் ஸோ n factorial divided by 10 power n. ஸோ ஒரு 10 power n கேன்சல் பண்ணிடலாம். அண்ட் n plus 1 factorial. ஸோ n factorial கம்ப்ளீட்டாக அடிச்சிட்டா this is n plus 1 into n factorial எழுதலாம். ஸோ இந்த n factorial கேன்சல் ஆகிடும். ஸோ 10 by n plus 1 வரும். So 10 by n plus 1. So we want to prove that this one, that is equivalent to this is less than 1. So 10 by n plus 1 is less than 1. Okay, so that means 10 by n plus 1 less than 1 னா இதை ஆக்சுவலி நம்ம ப்ரூவ் பண்ணணும். less than 1 ன்னு ப்ரூவ் பண்ணணும். இந்த less than 1 ன்னு எடுத்துட்டா I will try to find out the stage அந்த capital N ன்றது என்னன்னு கண்டுபிடிக்கலாம். So 10 less than n plus 1. So n greater than 9, n greater than 9. Okay, so the n greater than equal to 10 is the correct answer. Because of I will try to find the n greater than equal to n க்கு sn plus 1 less than sn. So இது n greater than 9 வருது. நான் equality போட்டேன்னா n greater than equal to 10. That is natural number. That is positive integer ன்றதுனால. So sn plus 1 less than sn for the n greater than equal to 10. அப்படின்னா what is the capital n? Capital n the stage வந்து that is called the 10. Capital N ன்றது here 10. So S10 ன்றது this is the S10, this is the S11. So from this S11 is less than S10. Okay, for the n equal to 10. And another sequence for n belongs to I, Sn is defined as 1 into 3 into 5 and so on 2n minus 1, 2 into 4 into 6 and so on 2n. Then Sn is convergent and limit n tends to infinity Sn less than or equal to 1 by 2, less than or equal to 1 by 2. So then Sn equal to the product of k equal to 1 to n, 2k minus 1 divided by 2k, 2k minus 1 divided by 2k. So this is, I will try to prove this is the Sn is convergent and the limit of the sequence is less than or equal to 1 by 2. So for that the sequence is 1 into 3 into 5 to 2n minus 1 divided by 2 into 4 into 6 2n. So the Sn இது எல்லாமே ப்ராடக்ட்ல இருக்கு, அதனால இந்த சிம்பிள் ப்ராடக்ட் சிம்பிள் யூஸ் பண்ணி you can write 2k minus 1 divided by 2k ன்னு எடுத்திருக்கோம் using the product symbol use பண்ணி. So for each k greater than equal to 1, the 2k minus 1 divided by 2k is less than 1. Obviously 2k minus 1 is சின்ன value, 2k ன்றது பெரிய value compared to this one. So சின்ன value divided by பெரிய value னா obviously less than 1. So Sn plus 1 equal to Sn into that is 2n plus 1 divided by 2n plus 2. So when you substitute here, this is the 2n plus 1 divided by 2n plus 2, that is less than Sn, less than Sn. And so which means that the sequence is strictly decreasing. So 2 into n plus 1, obviously correct, minus 1 divided by 2 into n plus 1. So this is equal to 2n plus 2 minus 1 divided by 2n plus 2. Okay. So this is 2n plus 1 divided by 2n plus 2. So Sn plus 1 equal to 2n plus 1 divided by 2n plus 2. So this is equal into Sn. Okay. So this is the Sn plus 1 defined as in the Sn plus 1 under the Sn into and the n plus 1th term, n plus 1th term. So in the Sn into n plus 1th term is nothing but less than Sn. So நமக்கு கிடைச்சிருக்கிறது Sn plus 1 less than Sn வந்திருக்கு ப்ராடக்ட்ல இருக்கிறதுனால. So Sn into n plus 1th term. So இது வந்து நமக்கு வந்து less than Sn தெரியும். So Sn plus 1 less than Sn. So from this Sn greater than Sn plus 1. So it's a strictly decreasing. It's a strictly decreasing sequence. And also Sn is greater than 0 for all n. For all n, this is greater than 0. So the sequence is bounded below. It's a decreasing sequence. And also this is converges to by 0. So therefore it is convergent. So Sn is non-increasing and bounded below. So it is converges some limit L. L is greater than equal to 0. Okay. And what about the nature of the Sn square? The nature of Sn square, this is the whole square. The product is whole square. So that is 2k minus 1 whole square divided by 2k square. So the a minus b whole square formula explain பண்ணீங்கன்னா like this. இதை split பண்ணீங்கன்னா 1 minus 1 by k plus 1 by 4k square. Am I correct? So the Sn with 1 by 2n that is Sn less than 1 by root of 2n. So that is product symbol, that is the Sn equal to the 2n factorial divided by 2 power 2n into, that is called the Wallis product or inequality, that is Sn equal to 2n factorial divided by 2 power 2n n factorial whole square. So that means இங்கே வந்து 2 காமனாக வெளியே எடுக்கணும், that is 2 into 1, 2 into 2, 2 into 3, 2 into n, that is n factorial, that is 2 into n factorial. So 2 power n into n factorial. When you square it, that is 2 power 2n into n factorial whole square. The numerator, that is the whole square, that is the 2n factorial, 2n factorial. And this is equivalent to Sn equal to, so then 1 by 4 power n, 2 square to the 4 power n, 2n cn. So that is limit n tends to infinity Sn is equal to 0. As n tends to infinity, this is become the 0. So that for the limit, that is L is now L is less than or equal to 1 by 2. So that means S1, this is 1 by 2, S2, this is S3. So S1 is 1 by 2. So Sn is less than or equal to 1 by 2. Maximum value is 1 by 2. This is the 0.3, this is 0 point something. So L is less than or equal to 1 by 2. And this is another problem. Okay, try பண்ணுங்க, that is S1 greater than S2 greater than S3. இதுவும் ப்ராடக்டில் தான் எக்ஸ்பிரஸ் பண்ணியிருக்கோம். ஸோ 2 into 4 into 6 2n divided by 1 into 3 into 5 2n minus 1 by n square. That is, this sequence is a non-increasing sequence, that is a decreasing sequence. So when you try to find out the S1 here, that is 2, S2 here 2 by 3, S3 here, that is like that. So இது மாதிரி ஃபைண்ட் அவுட் பண்ணி கூட நம்ம செக் பண்ணலாம், that is decreasing sequence or increasing sequence. ப்ரீவியஸ் ப்ராப்ளத்துக்கு இதை அப்ளை பண்ணியிருக்கலாம். So when you try to find out that Sn plus 1 divided by Sn, இதை சிம்பிளி பண்ணிங்கன்னா, that is 2n plus 2 divided by 2n plus 1, that is into n square by n plus 1 whole square. So இதை கம்ப்ளீட்டாக சிம்பிளி பண்ணிங்கன்னா, that is n plus 1 கேன்சல் ஆகிடும், and 2n by n plus 1, 2n by 2n plus 1, n by n plus 1. So this is 2n square divided by 2n plus 1 into n plus 1. So this is less than or equal to 1, and when you cross multiply it, we get it 0 less than or equal to 3n plus 1 வரும். So this is 2n square less than or equal to this one. இதை multiply பண்ணிங்கன்னா இது 2n square cancel ஆகிடுச்சுன்னா 3n plus 1 greater than equal to 1. So for which is true for all n greater than equal to 1. N greater than equal to 1, this is true. So therefore Sn plus 1 less than or equal to Sn for all n. Sn plus 1 less than or equal to Sn for all n. So the Sn is a non-increasing sequence. Non-increasing sequence. This is another example. This is the monotone sequence, that is and is bounded. So this is the limit is convergent. The sequence is convergent. இது ஃபார்முலா பார்த்தீங்கன்னா n into n plus 1 by 2. இது அப்ளை பண்ணிங்கன்னா n plus 1 by n into n plus 1 divided by 2n square, n plus 1 by 2n. இதை ஸ்ப்ளிட் பண்ணிங்கன்னா 1 by 2 plus 1 by 2n. ஸோ ஆப்வியஸ்லி பார்த்தாலே தெரியும், there is the Sn plus 1 minus Sn என்றது, that is equivalent to negative of value னு வருது. The negative value is less than 0 for all n. So Sn plus 1 less than Sn. So therefore the sequence is strictly decreasing and non-increasing sequence. So that the sequence is Sn equal to 1 by 2 plus 1 by 2n. As n tends infinity, this is converges to 1 by 2. And also 1 by 2n is greater than 0 for all n. So 1 by 2 less than Sn less than S1. Less than or equal to S1. S1 என்றது, that is 1. So from this is the bounded below by 1 by 2. Bounded below by 1 by 2. And therefore above by 1. Bounded above by 1. So it's a bounded sequence and is either increasing or decreasing, that is convergent. That is converges to 1 by 2 னு அர்த்தம். And another problem is the sequence of real numbers. Let Tn equal to S1 plus S2 plus and so on Sn divided by n. What is Sn என்றது the sequence of real number. T என்றது இதனுடைய average. The sequence Sn உடைய average, that is called the T S1 plus S2 plus Sn divided by n. Okay, average of the n terms of the sequence. And the Tn என்றது Sn என்றது is a monotone sequence and bounded. Then Tn is also monotone and bounded. Tn is also monotone and bounded அப்படின்னு சொல்லுவோம். So this is the idea. Sk is less than or equal to m na inge n less than or equal to m, that is also less than or equal to m nu வந்துரும். So this is the decrease monotonicity இருக்குனா, that is a Tn க்கு monotonicity இருக்குன்னு வரும். That is a very simple proof. Tn plus 1 minus Tn கண்டுபிடிச்சிக்கனாவே we get that output. And this is the another sequence Tn equal to 1 plus 1 by 1 factorial, 1 by 2 factorial, 1 by n factorial. The Tn என்றது is a non-decreasing sequence. Non-decreasing sequence on நம்ம செக் பண்ணனும்னா Tn plus 1 minus Tn கண்டுபிடிக்கணும். That should be Tn plus 1 greater than Tn வரணும். Okay. So then Tn is the increasing sequence. Non-decreasing means increasing. So Tn less than Tn plus 1 வரணும். So Tn plus 1 minus Tn கண்டுபிடிச்சோம்னா greater than 0 வரணும். இங்கே Tn plus 1 minus Tn கண்டுபிடிச்சோம்னா எல்லாம் cancel ஆயிட்டு 1 by n plus 1 factorial வரும். This is obviously greater than 0. So இதில் இருந்து Tn என்றது strictly increasing சொல்லலாம், that is non-decreasing sequence. And prove that Tn, the sequence is bounded above, and this is the limit of the Tn equal to greater than limit of the 1 plus 1 by n whole power n. So this is the increasing sequence, and upper bound இருக்கா அப்படின்னு பார்த்தீங்கன்னா Sn equal to, we know that for the sequence Sn equal to 1 plus 1 by n whole power n, when you expand the binomial expansion expand பண்ணீங்கன்னா that is Sn equal to 1 plus 1 by 2 factorial, 1 minus 1 by n, 1 by 3 factorial, 1 minus 1 by n, 1 minus 2 by n, and 1 by n factorial, 1 minus 1 by n, and so on something. So each term in this expansion less than or equal to the corresponding term in Tn. Okay, so 1 minus k by n less than 1. Okay, but the factors வந்து 1 minus k by n less than 1. So Sn has the fewer terms than Tn. So Sn is less than or equal to Tn. Okay, so therefore what is the conclusion அப்படின்னு பார்த்தீங்கன்னா, the Tn is a non-decreasing sequence, that is increasing sequence and bounded above by 3. So it is converges, that is Sn less than or equal to 3 என்றதுனால. So the limit of the sequence Tn is, I give the name T, limit of the sequence Sn is E. So the Sn is less than or equal to less than Tn for all n. So when you compare this one, E equal to limit of the sequence Sn less than or equal to limit of the sequence Tn. So that is equal to T. That is already நம்ம prove பண்ணிருக்கோம். The sequence ரெண்டும் less than or equal to, the corresponding limit is less than or equal to something. So therefore the value of this one is equivalent to E. Okay. And leave it to this problem. And S and T என்றது ரெண்டு sequence of real number na, and sequence of real number both have the limit L, M, ரெண்டுத்துக்கு லிமிட் இருக்கு, எக்ஸிஸ்ட் ஆகுது அப்படின்னா அதனுடைய சம்முக்கு is also limit இருக்கும். அதனுடைய சம்முக்கு லிமிட் வந்து அது ரெண்டுத்தினுடைய அடிஷனாக இருக்கும். ஸோ லிமிட் ஆஃப் த சம் இஸ் த சம் ஆஃப் த லிமிட். அதே மாதிரி Sn as a sequence of real number, அதுக்கு லிமிட் L இருக்குன்னா ஒரு சம் ரியல் நம்பர் மல்டிப்ளை பண்ணிங்கன்னா Cன்றது, அதே மாதிரி அந்த லிமிட்லெஸ் ரியல் நம்பர் மல்டிப்ளை பண்ணி நமக்கு அவுட்புட் கிடைக்கும். CSN உடைய லிமிட் CL, Snக்கு லிமிட் L இருந்ததுன்னா. அதே மாதிரி ரெண்டுத்தினுடைய டிஃப்ரென்ஸுக்கு பார்த்தீங்கன்னா L மைனஸ் எம்னு வந்துடும். and the geometric sequence, that is a very important one. Very important result. Okay, the x is lies between the 0 and 1. 0 க்கு 1 க்கு இடையில இருக்கு x அப்படினா the x power n என்றது converges to 0. x power n என்றது converges to 0. Okay, and the x என்றது lies between the 1 to infinity. 1 less than x less than infinity. Now x power n diverges to infinity. x power n diverges to infinity. Okay, that is 0 க்கு 1 க்கு இடையில இருக்குனா x power n converges to 0. I thought sometime mod x less than 1 ன்னு போடுவாங்க. mod x less than 1 னாலும் the x power n converges to 0. Okay, and this Sn and Tn both are convergent sequence with the condition Sn less than equal to Tn, and Sn க்கு லிமிட் வந்து L, Tn க்கு லிமிட் m னா L less than or equal to m. இப்போ just பாருங்க கடைசி எக்ஸாம்பிள் like that. and the limit of the squares பார்த்தீங்கன்னா Sn க்கு லிமிட் வந்து L ன்னு இருக்கு. Sn ஸ்கொயர் க்கு லிமிட் is also L ஸ்கொயர். ஓகேவா, Sn ஸ்கொயர் னுடைய லிமிட் L ஸ்கொயர். Sn க்கு லிமிட் L ஆ இருந்ததுனா அதே மாதிரி Sn Tn க்கு லிமிட் இருக்கு அப்படினா ப்ராடக்ட்க்கு Sn Tn க்கு இதுக்கு என்ன லிமிட்டோ அது ரெண்டுத்தையும் ப்ராடக்ட் பண்ணீங்கனா the product னுடைய சீக்வென்ஸ்க்கு லிமிட் Lm. and the quotient rule பார்த்தீங்கன்னா very important one, and Tn க்கு சீக்வென்ஸ் வந்து m ஆ இருக்கு அப்படினா 1 by Tn க்கு என்ன வரும்னா m is not equal to 0 வா இருக்கணும், then 1 by m. and the Sn by Tn க்கு என்ன வரும்னா Sn க்கு லிமிட் L, Tn க்கு m ஆ இருந்ததுனா m is non zero வா இருந்தா Sn by Tn ன்றது L by m is the limit. and this is one of the problem. so then என்ன பண்ணலாம் இங்க, that is n square வெளிய எடுக்கலாம். மேல வெளிய எடுத்தீங்கன்னா that is 3 minus 6n by n square. இங்க கீழே வந்து n square வெளிய எடுக்கலாம். வெளிய எடுத்தீங்கன்னா 5 plus 4 by n square. so இந்த வெளிய எடுத்த n square அடிச்சிட்டீங்கன்னா இந்த அவுட்புட் வரும். இதுல லிமிட் போட்டீங்கன்னா anything by infinity 0, இங்கே 0, so the answer is 3 by 5. okay, இதான் நாம பார்த்த ரிசல்ட் அவுட்புட். This is also another problem, that is divided by n square, sorry n cube. மேலே n cube வெளிய எடுக்கலாம். then 2 plus 5n by n cube. இங்க கீழே n cube வெளிய எடுத்தீங்கன்னா 4 plus n square by n cube. இங்க ஒரு n அடிச்சிட்டா கீழே n square வரும். இங்க n square அடிச்சிட்டா that is the n. okay, so this is equivalent to 2 by 4, that is equal to 1 by 2. okay, so n square by n minus 7 whole square minus 6. so this is equivalent to இதை எக்ஸ்பெண்ட் பண்ணிட்டு இது மாதிரி ஸோ நம்பரை கலெக்ட் பண்ணிட்டீங்கன்னா n ஸ்கொயரை காமனாக வெளியே எடுத்த பிறகு லிமிட்டை அப்ளை பண்ணிங்கன்னா we get the limit of the sequence. and Sn converges to 1. Sn power 1 by 2 root Sn Sn converges to 1, Sn power 1 by 2, n equal to 1 to infinity, root of Sn converges to 1. That is also some result. okay, root Sn க்கும் limit 1 ன்னு அர்த்தம். Sn converges to 1 னா ஸோ இது நம்ம கொடுத்துருக்காங்க, இதுக்கு இதை ப்ரூவ் பண்ணணும். root of Sn minus 1 நம்ம எடுத்துட்டா ஜஸ்ட்டு என்ன பண்ணலாம், that is root of Sn minus 1, Sn minus 1 divided by root of Sn plus 1 multiply பண்ணி divide பண்ணலாம். root of Sn plus 1 multiply பண்ணி divide பண்ணிங்கன்னா மேலே என்ன ஆகும்னா Sn minus 1 ஆகிடும், கீழே வந்து root of Sn plus 1 வந்துடும். ஆக்சுவலி பார்த்தீங்கன்னா Sn converges to 1 கொடுத்துருக்காங்க for a large n. ஓகேவா, so that is Sn so the root of Sn plus 1 greater than equal to 1. So that Sn greater than 0 ன்றதுனால Sn converges to 1 for large n க்கு. So root of Sn plus 1 ன்றது that is greater than equal to 1. Therefore root of Sn minus 1 ன்றது is less than equal to Sn minus 1. So this is, what is the conclusion? Less than epsilon, because of Sn is converges to 1 ன்றதுனால. So root Sn is also converges to 1. சும்மா ட்ரை பண்ணுங்க, சின்ன சின்ன ப்ரூஃப்லாம் நீங்கள் பார்க்கலாம், பெருசாக இருக்கிறத leave it. And this is another very important problem, that is cube root of n divided by root of n plus 1 minus root n. Already we know that is limit of the cube root of n is 1. That means limit n tends infinity n power 1 by n. Okay, this is equal to 1. So the another one வந்து இதை காஞ்சுகேட் எடுத்து போகணும். நேற்று பார்த்தோம்னு நினைக்கிறேன். இதை காஞ்சுகேட் எடுத்திங்கன்னா that is okay 1 by root of n plus 1 plus root n. So that nth root of n 1 by root n plus 1 plus root n. So this is converges to 1. What about this one? This is converges to 0. இது Sn, இது Tn வச்சிங்கன்னா the product is converges to 1 into 0, that is equal to 0. And the Sn is the sequence of positive numbers and the x is sliced between the 0 to 1. Okay, the Sn plus 1 less than x into Sn. X into Sn. So the limit of the Sn plus 1 less than x into Xn, the limit of the Sn is equal to 0. Limit of the sequence Sn equal to 0. So Sn plus 1 less than x into Sn means Sn x power n minus 1 less than S1 for all n greater than equal to 1 by the induction. X is sliced between the 0 to 1. So limit of the x power n minus 1 converges to 0. So that this is converges to 0. Sn is converges to 0. Okay. So we can construct that that is S1 S2 less than x S1, S3 less than x S2. Am I correct? N equal to protect S3 x less than S2. This is less than x into x S1. So this is nothing but the x square S1, x square S1. So S3 less than x square S1. So this is the idea. Okay. So x power n minus 1 is converges to 0 as x is sliced between the 0 and the 1. So apply பண்ணீங்கன்னா Sn converges to 0. This is the another problem. Sn minus 1 divided by Sn plus 1 is equal to 0. Limit n tends to infinity. So the limit of the Sn equal to 1. So when you take the epsilon n equal to Sn minus 1 divided by Sn plus 1. So when you cross multiply epsilon n into Sn plus 1 equal to Sn minus 1. So then for this Sn in terms of epsilon. So in terms of epsilon, so already we know that this is converges to 0. So limit Sn equal to this is 0, this is 0. So 1 by 1, that is equal to 1. Okay, it's a very simple proof. And another result is limit n tends to infinity 1 plus 1 by n whole power n plus 1 equal to e. Already நாம் பார்த்தோம், that is whole power n equal to e. So then 1 plus 1 by n plus 1 whole power n equal to e. Because of we know that this one already நாம் பார்த்தது தான் 1 plus 1 by n whole power n equal to e ன்றது. And this is equivalent to this one into then பிரிக்கலாம் 1 by 1 1 by n 1 plus 1 by n whole power n plus 1 whole power n into whole power 1 ன்னு பிரிக்கலாம். இதுக்கு வேல்யூ e, இதுக்கு வேல்யூ as n tends infinity 1 by infinity 0, that is 1. So this is equal to e. நமக்கு தேவை இதுதான். 1 plus 1 by n plus 1 whole power n, that is whole power n plus 1 into minus 1 ன்னு பிரிக்கலாம். The value of this one is e and the value of this one is 1, so e into 1 equal to e. And another 1 plus 2n is equal to 1 plus 1 by n plus 1 into 1 plus 1 by n. So then limit n tends to infinity 1 plus 2 by n whole power n. This is equal to e square. So this is the identity, that is 1 plus 2 by n whole power n, that is 1 plus 1 by n plus 1 into 1 plus 1 by n whole power n. இது நமக்கு என்னன்னு தெரியும், whole power n. இதுக்கு என்னன்னு தெரியும். So ரெண்டுதுமே e into e ன்றது, that is called the e square. So இனிமே ஃபார்முலாவை ஞாபகம் வச்சுக்கணும், that is the limit n tends to infinity 1 plus 2 by n whole power n னா that is called the e square. இங்கே 3 by n வந்ததுன்னா that is called the e cube, like that. So that limit n tends to infinity 1 plus 1 by n plus 1 whole power n equal to e, that is. If c is greater than 1, then limit n tends to infinity c power 1 by n equal to 1. As n tends to infinity, the c லாம் போட்டிங்கன்னா as n tends to 1 by infinity 0, c power 0. c power 0 value is 1. That is another way, another type of proof. And s1 equal to root 2 and s1 equal to root 2, sn plus 1 equal to root 2 into sn, root 2 into sn, and n greater than equal to 1, and that then sn is less than or equal to 2 for all n. Sn is less than or equal to 2 for all n in the case of s1 equal to root 2. So s1 equal to root 2 na root 2 ன்றது less than or equal to 2. Okay, and sn is what is that, s1 is less than or equal to 2. So s2 the same way, sn is less than or equal to 2. அப்படின்னா sn plus 1 is எப்படி டிஃபைன் பண்ணலாம், root 2 into root sn. So sn is less than or equal to 2, இந்த root 2 அப்படியே வந்துடும், and root sn is the root 2 less than or equal to root 2. Root 2 into root 2, that is 2. So sn plus 1 is also less than or equal to 2. Sn less than or equal to 2, sn plus 1 less than or equal to 2. So from this we get the conclusion. அதே மாதிரி sn plus 1 greater than equal to sn. So that means root 2 into root sn greater than equal to sn. That is 2 into, that is root 2 into, that is root sn for the sn plus 1. That is greater than equal to sn. So from this squaring at both sides, then 2sn greater than equal to sn square. That means sn square minus 2sn, sn into sn minus 2 less than equal to 0. That means sn is lies between the 0 and 2. sn என்றது lies between the 0 and 2. That is from this, what is the conclusion? That is sn plus 1 is greater than equal to sn. Sn plus 1 greater than equal to sn. So the sn is convergent, that is sn is non-decreasing. இப்போ தான் sn plus 1 greater than equal to something பார்த்தோம். Non-decreasing sequence, that is increasing sequence. So and upper bound இருக்கு, 2 இருக்கு. So from this the sequence is converges. And the converges ஆகிறது எதுக்குன்னு பார்த்தீங்கன்னா that is the 2. So limit equal to L ன்னு வச்சுக்கலாம். So that is sn plus 1 equal to root 2 sn. So taking limit both sides, then L equal to root 2 root L ன்னு வரும். And then from this root L equal to root 2, squaring on both sides, L equal to 2. So that is all result. Okay. So கொஞ்சம் இன்ட்ரெஸ்டிங்கான ப்ராப்ளம் தான். அண்ட் another problem பார்த்தீங்கன்னா s1 greater than s2 greater than 0, sn plus 1 equal to 1 by 2 sn plus sn minus 1, sn plus sn minus 1 whole divided by 2 for all n greater than equal to 2. So இதில் பார்த்தீங்கன்னா s1 s3 s5ன்றது is a non increasing, s2 s4 s6ன்றது non decreasing, snன்றது is a convergent sequence. So for that the first one பார்த்தீங்கன்னா that is s2k minus 1 greater than equal to s2k plus 1 சொல்லணும். That means s2k is the s2k is less than or equal to s2k plus 2 for all k greater than equal to 1. So when you take the k equal to 1, s3 equal to that is s2 plus s1 divided by 2 by the definition. s1 minus s3 கண்டுபிடிச்சிங்கன்னா s1 minus s3, so இது சிம்பிளி பண்ணிங்கன்னா half into s1 minus s2. the s1 minus s2ன்றது okay s1 greater than s2 தெரியும், s1 is greater than s2, so that s1 minus s2 is greater than 0, so therefore s1 minus s3 is greater than 0. when you try to find out the s4, s4ன்றது 1 by 2 s3 plus s2, 1 by 2 s3 plus s2, so s4 minus s2 that is s4ன்றது minus s2, so s3 minus s2 வந்துரும். so since s1 greater than s2, s3ன்றது 1 by 2 s1 plus s2 divided by 2, so s1 greater than s3 greater than s2, so from this s4 minus s2ன்றது greater than 0, so s4 greater than s2. so ரெண்டுமே நம்ம ப்ரூவ் பண்ணிட்டோம், that is idea. so that even term and odd term இருக்கு, இதை generalize பண்ணிங்கன்னா obviously true, so therefore both sequences are bounded, that is also converges. okay, even term and odd term sequences. in the case of இது மாதிரி define பண்ணும் பொழுது that is converges. Sn பார்த்தீங்கன்னா between the Rn and the Tn, both Rn and Tn converges to S. Sன்றது lies between the Rn and Tn, two sequence இடையில இருக்கு. both sequences Rn and Tnன்றது converges to S. அப்படின்னா the sequence Sன்றது converges to S. அது like that sandwich theorem. ஓகேவா? ஸோ இது ரெண்டுமே converges to some வேல்யூனா நடுவில் இருக்கிறது converges to the same value அப்படின்னு அர்த்தம். ஓகே, just definition யூஸ் பண்ணலாம். this is the definition of Rn converges to S, this is the and this is the definition of Tn converges to S. so from this S minus epsilon less than Rn, that is இதில் இருந்து Tn is the less than epsilon. so that is S minus epsilon less than Rn less than equal to Sn. so from this we get the conclusion. Sn என்றது S minus epsilonக்கும் S plus epsilonக்கும் இடையில இருக்கு. so Sn minus S என்றது less than epsilon எடுக்கலாம், therefore Sn is converges to S. this is called the skews theorem அப்படின்னு அர்த்தம். this is called the skews theorem. and diverges to infinity, that is the operation on the divergent sequence. இப்போ எவ்வளோ நேரம் பார்த்தது that is the convergent sequence உடைய operations. so S and T என்றது both are diverges to infinity na, and their sum is diverges to infinity and product is diverges to infinity. ரெண்டு தனித்தனியாக diverges to infinity na, sum and product என்றது diverges to infinity. just use the definition. okay, diverges to infinity means capital M greater than 0. Sn is converges to infinity, Tn converges to infinity now. There exists some stage capital N such that n greater than equal to capital N, Sn greater than m by 2 and Tn greater than m by 2. so then for all n greater than equal to n, that is the definition of the diverges to infinity. then Sn plus Tn is greater than m by 2 plus m by 2, that is called the m. So this is the proof. Okay. இதே மாதிரி ப்ராடக்ட் பார்த்தீங்கன்னா after the stage of the capital N, Sn greater than root m for some positive real number, there exists the stage n and Tn is also greater than root m. Because of Sn Tn both are diverges to infinity என்றதனால the product is greater than equal to root m into root m, that is called the m. Okay, so it's a very simple proof. And Sn is Sn Tn both are sequences real number, both are diverges to infinity. Sn diverges to infinity, Tn is bounded, then Sn plus Tn is diverges to infinity. So first பார்த்தது ரெண்டு both are diverges to infinity னா அதனுடைய sum is diverges to infinity and product is diverges to infinity. இங்க ஒன்று வந்து diverges to infinity, இன்னொன்று வந்து bounded, then the sum is diverges to infinity. So the bounded na namakku enna theriyum, that is that there exists some positive real number and modulus of the sequence is always less than equal to m for every n, and Sn is diverges to infinity na, that is that there exists some stage, and the stage la Sn என்றது greater than அந்த real number ஆ இருக்கணும். Okay, after the stage இந்த ரெண்டுத்தையும் கம்பைன் பண்ணிங்கன்னா Sn plus Tn என்ன வரும் அப்படின்னு பார்த்தீங்கன்னா Sn is greater than m plus b ன்னு எடுத்துருக்கோம். that's our idea. So இங்கே Sn plus Tn கண்டுபிடிக்கும்போது m plus b minus b. Okay, then m greater than m ன்னு வந்துருது for the real number m after the stage capital N. So that this is a Sn plus Tn diverges to infinity. அதே மாதிரி Snன்றது diverges to infinity, Tnன்றது converges. ஒன்று diverges to infinity, இன்னொன்று converges இருக்குது அப்படின்னா sum is diverges to infinity. So every convergent sequence is bounded. Tn is the convergent sequence na, that is bounded அர்த்தம். So previous theorem apply பண்ணீங்கன்னா that is called the sum is diverges to infinity. அதே மாதிரி operation of the oscillate sequence, that is almost any kind of the sequence can be formed from the sum of the two properly chosen oscillate sequence, that is sum of the oscillate sequence. So this is the one of the oscillate sequence, this is another oscillate sequence. இது ரெண்டுத்தையும் சம் பண்ணிங்கன்னா என்ன கிடைக்குதுன்னா diverges to infinity வருது. Okay, so sum of the oscillating sequence, this is another sequence. Okay, oscillate sequence, this is another sequence, oscillate sequence. So this is the ரெண்டுத்தையும் ஆட் பண்ணும்போது என்ன வருதுன்னா கான்ஸ்டன்ட் சீக்வன்ஸ் வருது, that is the convergence. ஸோ இதுலேருந்து நம்ம எந்த கன்க்ளூஷனும் பண்ண முடியாது. ஸோ சம் ஆஃப் த ஆசிலேட் சீக்வன்ஸ் with itself oscillating, sum of an oscillate sequence is itself is oscillating. Okay, and Sn Tn that is both are diverges to infinity. One is diverges to plus infinity, another one is diverges to minus infinity. The sum is diverges to plus infinity. Plus infinity. Can give the name very simple. Example, Sn equal to 2n, Tn equal to minus n. Then we get the output. And another one, the difference is okay, converges to 7. Sn equal to n plus n, Tn equal to n, then this is diverges to infinity, this is also diverges to infinity, but the difference is the constant sequence, that is converges to 7. Okay, like that. And Sn is diverges sequence of real number, C into any real number, Csn is the diverges, அதே மாதிரி Snன்றது oscillating sequence and not bounded, Tnன்றது bounded அப்படின்னா that is the Sn plus Tnன்றது is oscillating not bounded. Okay, true ஆன்னு கேட்டிங்கன்னா that is the true. We can prove. so Sn equal to n square, Tn equal to minus n, both are diverges to plus infinity and minus infinity. Okay, that is over. And another topic was the limit superior and limit inferior. So first of all, what I mean the limit superior, limit inferior means the sequence of real number is bounded above. Define mn equal to least upper bound. Okay, mn equal to least upper bound of the Sn plus 1 and Sn plus 2. Okay, so then mn is the sequence mn is non-increasing sequence, that is called the decreasing sequence. If mn is converges, the limit supremum of the Sn limit supremum of Sn equal to limit of the mn, and mn is diverges to minus infinity, limit supremum of Sn is equal to minus infinity. Okay, so that means what do you mean the Sn is Sn, the Sn is not bounded above, and not bounded above, then limit supremum of the Sn equal to plus infinity. Sn is bounded below now, that is called the small mn equal to greatest lower bound of Sn plus 1, Sn plus 2 and so on. And the mn is non-decreasing sequence, the small mn, greatest lower bound of the collection of Sn plus 1 and so on. And the mn is converges, or that is the limit infimum is equivalent to limit of the mn. Okay, if mn is diverges to plus infinity, the limit infimum is diverges to plus infinity. Not bounded below this lower bound illana, the sequence limit infimum of Sn is equal to minus infinity. So then the limit supremum for the minus 1 power n, that is equal to 1, limit infimum of the minus 1 power n, that is equal to minus 1, and limit supremum of the n equal to infinity, limit infimum of the n equal to infinity. The same way limit superior and limit inferior. Okay, so this is the one of the oscillate sequence. இதுக்கு limit superior பார்த்தீங்கன்னா that is called the 1, and limit inferior is that is minus 1, minus 2 and minus 3 and so on. So that is called the limit infimum is minus infinity. The sequence is converges to L, na, that is limit superior is equal to limit inferior, that is called that limit superior equal to L in artham. The sequence is converges to L, na, limit inferior equal to L in artham. Limit superior, limit inferior both are equal in the case of the sequence is converges to some value, na, that value ku adu rendu equal. And for any sequence Sn, limit inferior less than or equal to limit superior for any sequence. Sn limit inferior is always less than or equal to limit superior. அதே மாதிரி limit superior, limit inferior both are equal to L, na, the sequence is converges to L in artham. The sequence is converges to L. Limit superior, limit inferior both are diverges to infinity, na, the sequence is diverges to infinity in artham. And in the case of Sn less than or equal to Tn, that is Sn less than or equal to Tn for all n, na, the limit superior is less than or equal to limit superior, and limit inferior less than or equal to limit inferior. And for the bounded sequences Sn and Tn, limit superior of Sn plus Tn is less than or equal to limit superior of Sn, limit superior of Tn. Limit inferior of Sn plus Tn greater than or equal to limit inferior of Sn, limit inferior of Tn. இதெல்லாம் very very important result. இதெல்லாம் mostly கேட்டிருக்காங்க. Okay. And the sequence is bounded, then limit superior, if the limit superior of the Sn equal to m, for any then for any epsilon greater than 0, Sn less than m plus epsilon எடுதலாம், but for all but finitely many n. Okay, the Sn greater than m minus epsilon for all, for infinitely many n. The same way limit inferior equal to m ன்னு நாம் எடுத்துட்டோம். For any epsilon greater than 0, Sn greater than m minus epsilon, greater than m minus epsilon for all, and but finitely many n, m Sn less than m plus epsilon, inferior க்கு like this. கொஞ்சம் உல்டாவா இருக்கும். This is also very important. In the case of the sequence is bounded. Sequence is bounded ஆகுதுனா. This is a very important theorem, the Bolzano-Weierstrass theorem. Any bounded sequence of real numbers as a bounded sequence of real numbers as a convergent subsequence. As a convergent subsequence. However, changing finitely many terms doesn't affect the limit superior and the limit inferior. Okay, changing the finitely many terms. Limit superior is the largest subsequential limit, and the limit inferior is the smallest subsequential limit. And the sequence converges now, limit superior, limit inferior both are equal. For convergent sequence, limit superior, limit inferior, limit மூணுமே equal ஆக இருக்கும். And this is the example. Then for the find the limit superior and the limit inferior for the following this sequence. So the sequence pathina, that is an oscillate sequence like that, periodic, that is 1 2 3 1 2 3 1 2 3. Okay, period on the 3 adukapra repeat agudhu. So for any n, the sequence Sn plus 1, what is that? Sn plus 1 is also the periodic. Sn என்றது 1 இருக்குனா Sn plus 1 2 இருக்கும், Sn plus 3 Sn plus 2 ன்றது 3 இருக்கும். இல்ல இது 3 இருக்குனா அடுத்து 1 இது 2 like that. So capital M என்றது least upper bound of the collection of Sn plus 1, Sn plus 2. So what is that? That is always 1 2 3. Order மாறி இருக்கலாம். So that is what is the limit least upper bound of this one? That is the 3 for all n. The same way small m and the greatest lower bound of 1 2 3 2 3 1 கூட எடுத்துக்கேன், that is and so on. So what is the greatest lower bound? That is called the 1. So the limit supremum for this problem 3 and the limit infimum for this problem 1. So what about the sin n pi by 2? That is a very important problem. Sin n pi by 2. When you take that n equal to 1, நேத்தே பார்த்தோம் இது sin n pi by 2 னுடைய நேச்சர். sin pi by 2 1, n equal to 2 na 0, n equal to 3 na minus 1, n equal to 4 na 0, n equal to 5 na plus 1, n equal to 6 na 0, n equal to 7 na minus 1, n equal to 8 na 0. So இதுவும் oscillate ஆகுது. That is the periodic of 1 0 minus 1, 1 0 minus 1 and 0 1 0 minus 1 0, 1 0 minus 1 0 like that. So after the n, for any n, the sequence Sn plus 1 and so on, என்ன கண்டெயின் பண்ணியிருக்கும்? கண்டிப்பாக வந்து -1 0 1 இருக்கும். ஓகே, ஏதோ ஸ்டேஜில் -1 0 கண்டிப்பாக கண்டெயின் பண்ணியிருக்கோம். ஆஃப்டர் த n minus 1 the stage, that is n Sn plus 1 and so on, the sequence contain -1 0 and 1. So what is the least upper bound for this one? 1. The greatest lower bound is the -1. So the limit supremum, limit infimum for this one 1. Suppose both are same, or the sequence is the convergent, that is converges to the same limit. It 1 plus 1 by n into cos n pi. Cos n pi நேத்தே பார்த்து, that is cos n pi value -1 power n. So Sn equal to 1 plus 1 by n into -1 power n. For the even number பார்த்தீங்கன்னா, for the even number n க்கு இது வந்து என்ன ஆகும் அப்படின்னு பார்த்தீங்கன்னா +1 ஆகிடும். அப்படின்னா 1 plus 1 by 2k, 1 plus 1 by 2k, that is converges to 1, that is converges to 1. And for the odd number பார்த்தீங்கன்னா 1 plus 1 by 2k minus 1, that is -1 ப்ராடக்டில் வரும், ரெண்டுமே மைனஸில் இருக்கும், that is converges to -1 for the odd numberக்கு. ஸோ நாம் இப்போ பார்த்தீங்கன்னா that is ஸோ mnன்றது என்னவாக இருக்கும் அப்படின்னு பார்த்தீங்கன்னா the least upper bound of Sn plus 1, Sn plus 2. So that is the values orbital close to both 1 and minus 1. Both 1 and minus 1. So in the case of Sn plus 1, Sn plus 2, so அதே மாதிரி Mn equal to greatest lower bound of Sn plus 1, Sn plus 2 na இதில் என்ன இருக்கும் அப்படின்னு பார்த்தீங்கன்னா that is 1 and 1 minus 1 like that 1 minus 1 ரெண்டுமே அப்படியே தான் இருக்கும், that is contain பண்ணியிருக்கும், that is 1 plus 1 by n. ஸோ ஈவனாக இருக்கலாம் ஆடாக இருக்கலாம் இல்லையா, ரெண்டு கேஸுமே இருக்கலாம் இந்த Sn plus 1. ஸோ இது ஈவனாக இருந்ததுன்னா இது ஆடு, இது ஈவனாக இருந்ததுன்னா இது ஆடு. ஆடுக்கு வந்து தட் இஸ் 1 plus 1 by சாரி ஈவனுக்கு 1 plus 1 by 2k, ஆடுக்கு minus 1 by minus 1 by 2k minus 1. ஸோ தட் திஸ் இஸ் நமக்கு தேவை வந்து லீஸ்ட் அப்பர் பவுண்டுன்றதுனால தட் இஸ் லீஸ்ட் அப்பர் பவுண்ட் இஸ் த plus 1 and greatest lower bound is the minus 1. Greatest lower bound is the minus 1. So least upper bound that is called the limit supremum is the plus 1, limit infimum is the minus 1. The next problem is 1 plus 1 by n whole power n. Obviously நமக்கு தெரியும் this is the convergent sequence ன்னு. இது convergent sequence limit is exist னா கண்ணமுடிட்டு சொல்லலாம் limit supremum limit infimum both are equal to the convergent value that is called the E. நீங்கள் limit supremum infimum கண்டுபிடிக்க வேணாம், convergent sequence are the limit supremum limit infimum both are equal. And the limit supremum of the sequence Sn is equal to m. Then limit supremum of the any subsequence of m Sn is less than or equal to m, is less than or equal to m. Limit supremum m இருக்குனா அதோட subsequence க்கு less than or equal to m ஆகும். So the sequence for any fixed k that is Snk is the subsequence. Okay, the subset this is a subset of Sn n greater than or equal to nk. So least upper bound of the subsequence, least upper bound of the sequence. Already நாம் பார்த்தோம் ரெண்டு sequence இருக்கா, that is the least upper bound of the subsequence is less than or equal to least upper bound of the sequence. Least upper bound of the sequence is the m n k, that is called as taking the limit k tends to infinity now. This is the least limit supremum of the Snk. This is called the limit supremum of m and k, that is equivalent to m. So the limit supremum of the Snk, the subsequence, is less than or equal to m, less than or equal to m. And Sn under the bounded sequence of real number, limit infimum is the Sn, limit infimum of the sequence Sn is m, small m. அதனுடைய subsequence வந்து converges to m, the subsequence which converges to m na, okay, and the no subsequence of Sn can converge to a limit less than m, okay, and this is the epsilon greater than 0 with it. And the sequence of real number diverges to infinity, then limit supremum limit infimum both are equal to infinity. இதே மாதிரி மைனஸ் இன்ஃபினிட்டிக்கு நம்ம சொல்லலாம். And the sequence has no convergent subsequence, the sequence on there has no convergent subsequence, then the modulus of Sn diverges to infinity, then the modulus of Sn diverges to infinity. And the sequence of real number, if sigma n equal to, that is called the average of the first n terms of the sequence sigma n, limit supremum of the sigma n is always less than or equal to limit supremum of Sn. Limit infimum of the sigma n is greater than or equal to limit infimum of the Sn. That is very important. இது மாதிரி டைரக்ட் கொஸ்டின் நிறைய கேட்கறதுக்கு வாய்ப்புகள் இருக்குது, மோஸ்ட்லி ப்ராப்ளம் தான் கேட்பாங்க. That is the Cauchy sequence. Cauchy sequence is the sequence of real number is called the Cauchy sequence. If for any epsilon greater than 0, there exists the stage capital N. The difference is okay. The differences of any sequence is always very close to each other. Difference of the any two sequence is always very close to each other after the stage of the capital N. After the stage of capital N, then the corresponding sequence is called the Cauchy sequence. That is mod of Sm minus Sn less than epsilon. Enter in the sequence after the stage of the capital N very close to each other. That is convergent sequence. Every convergent sequence is the Cauchy sequence. ரொம்ப சிம்பிளா மறந்து போச்சுனா கூட ப்ரூவ் பண்ணலாம். L equal to Sn னா that is the definition for the convergent sequence, that is converges to L என்று வைக்கும்போது m, n ன்றது greater than equal to n ன்னு ஸ்டேஜ் எடுத்துட்டீங்கன்னா Sm minus Sn எடுத்தீங்கன்னா L சப்ட்ராக்ட் பண்ணி L ஆட் பண்ணும்போது ட்ரையாங்கிள் இன்இக்வாலிட்டி அப்ளை பண்ணீங்கன்னா உங்களுக்கே தெரியாம அவுட்புட் கிடைக்கும். So Sm minus Sn ன்றது less than epsilon. So this is the Cauchy sequence. So convergent sequence of the Cauchy sequence இருக்கும். So this Cauchy sequence, every Cauchy sequence is bounded. So Cauchy sequence, now this is the Cauchy sequence definition. So that is for the after the stage of the capital N, this is true. In particular case, Sm minus Sn less than 1 எடுத்தீங்கன்னா that is triangle inequality apply பண்ணிட்டு Sm கண்டுபிடிச்சீங்க 1 plus Sm. This is the particular value, particular sequence. So capital N equal to m equal to maximum of the something எடுத்தீங்கன்னா so that is Sn is less than or equal to m னு வந்துரும், that is bounded. So Cauchy sequence இருந்தா bounded இருக்கும். இதெல்லாம் ரொம்ப முக்கியமான ரிசல்ட். இது கன்ஃபியூஸ் ஆகும் எக்ஸாம் டைமில், தப்பு போட்டு வந்துடுவோம். ஸோ அண்ட் the sequence is Cauchy sequence of real number, then it is converges. That is converges. That is remember nested interval theorem for each n belongs to n. That is in என்றது is the interval an comma bn, be closed bounded interval such that I1 is the superset of I2, I2 contains I3 and so on, in contains in plus 1 and so on. Limit n tends infinity, in என்றது nth interval, n tends infinity bn minus an equal to 0, then intersection of the in contains exactly one point, okay. That is the nested interval theorem. That is the Cauchy sequences converges in R, that is completeness of R, okay. Sn is a Cauchy sequence now which has a subsequence converges to L, which has a subsequence converges to L. Sn under the Cauchy sequence, then Sn under the converges to L. Sn is the converges to L. Sn under the Cauchy sequence இருந்து அதுக்கு subsequence வந்து converges to L இருந்ததுன்னா the sequence வந்து converges to L ன்னு அர்த்தம், okay. And this is the one of the example, that is the n belongs to Sn equal to the S to n minus Sn, that is Sn is not a Cauchy, okay. So S to n minus Sn voting, that is look at the result, that is greater than n times 1 by 2n. இது எல்லாமே greater than equal to each and every term 1 by n plus 1 greater than equal to 1 by 2n, 1 by n plus 2 greater than equal to 1 by 2n, 1 by 2n equal to 1 by 2n. So n times 1 by 2n போடலாம். So this is the n plus n, nothing but 2n ன்றது n plus n. So மொத்தம் n terms இருக்கு. So n times greater than 1 by 2n, that is greater than equal to 1 by 2. So from this for any n, m equal to 2n, n equal to n, the Sm minus Sn, S to n minus Sn ன்றது greater than equal to 1 by 2 வருது. So this is not a Cauchy. This is not a Cauchy sequence. Every subsequence of the Cauchy sequence is a Cauchy sequence. Every subsequence of the Cauchy sequence is a Cauchy sequence. That is a very important one. And the sequence of the closed intervals I1 contains I2, I2 contains I3, In, whose endpoints are the rational numbers, and intersection of In is equal to E. Intersection of In is equal to E. So E equal to limit n times infinity something தெரியும். So அதை யூஸ் பண்ணி proceed பண்ணலாம். E ன்றது இந்த இடத்துல value that is lies between the 2 and 3. And the problem ரொம்ப important, that is endpoints is the rational number. That is very important. An is the be a sequence of real number for each n belongs to I. Sn equal to a1 plus sum of the sequence, first n terms of the sequence. Tn is modulus of a1, modulus of a2, modulus of an. Tn is the Cauchy sequence, therefore Sn is the Cauchy sequence. Tn is the Cauchy sequence, Sn is the Cauchy sequence. The modulus of a1, modulus of a2, modulus of an is the Cauchy sequence. That is very important. And the interval In are not assumed to be closed. By example, the conclusion of that behold the interval In are not assumed to be closed. Open interval, that is nested interval theorem. That is not true in the case of the open interval. The case of open interval, that is not true. Nested interval theorem gives the new proof that 0,1 is not countable. 0,1 is not countable in the nested interval theorem.